Hey, this is Mr. Aiden. We're still in Unit 7 Diffie-Qs, and we're finding particular solutions to differential equations. What did we do in the last video? We found how to find your solutions. And remember, we had, in every one of those solutions, we had plus c, didn't we? Because we didn't have a particular solution. We didn't know what that constant was because we weren't given any original values. It's like knowing what your slope is but not knowing what your y-intercept is. You can't know what your y-intercept is unless you know a point on that graph. In the same way, today we're going to be taking a look at how to find particular solutions, exact solutions to our Diffie-Qs. So we're going to kind of cascade along in our difficulty. Okay, so we're going to start off pretty easy and we're going to keep getting a little bit more and more difficult. So you may want to practice these to find your particular solutions because they show up on almost every AP Calc exam. And so here, we know f of 2 is equal to 12. We want to know what f of negative 1 is. I don't know what it is, but they gave me a differential equation. They gave me the slope, the dy over dx, equals 24 over x cubed, or 24x to the negative 3. So what am I going to do? I'm going to do my separation of variables, aren't I? I'm going to put all my y's on one side, which I don't really have any y's, and I'm going to put all my x's on the other, 24x to the negative 3 dx. And what am I right here? I am primed and ready to integrate, aren't I? Primed and ready to integrate. So what's the integral of 1 dy is just y. What's the integral of 24x to the negative 3? Well, we're going to have to use that reverse power rule, aren't we? And we're going to get 24x to the negative 2 over negative 2, or negative 12x to the negative 2 plus c. Plus c. Don't forget that c. So that is what my function of y is equal to. Now, they told me that when f of 2 is equal to 12, which means when x is equal to 2, y is equal to 12. Which means I'm going to plug this in the equation. 12 is equal to negative 12, 2 to the negative 2 power, plus c. So what is this saying is 12 is equal to negative 12 over 2 squared over 4, that's negative 3, plus c. So what is c going to be? C is going to be 15, isn't it? C is going to be 15 for the particular solution. So my particular solution is of this Diffie-Q is y is equal to negative 12 over x squared plus 15. That is my particular solution, isn't it? Because that worked with the number they gave me. Y equals negative 12 over x squared plus 15. Now they said at the end of the day, we want to know what f of negative 1 is. So y is equal to negative 12 over negative 1 squared. We're plugging negative in 1 for x plus 15. So we get negative 12 plus 15 is 3. So that answer is equal to 3. And that is my particular solution. Let's take a look at another one, a little bit more difficult one, but still fine. We have my differential equation. We have my dy over dx is equal to 5e to the x. I want to separate my variables, so I have dy is equal to 5e to the x dx, and what do you know? This is primed and ready to integrate, isn't it? What's the integral of 1 dy is y. What's the integral of 5e to the x? Well, that's 5e to the x plus c, isn't it? Now, remember, that is just my general solution. General solution, solute. And so that is just my general solution. That's not my particular solution. From my particular solution, I need to plug in numbers that I know. I know when x is 7, y is 40 plus 5e to the 7. So y is equal to 40 plus 5e to the 7 when when x is equal to 7 plus c. So obviously, what is c equal to? C has got to be equal to 40, isn't it? Because we have 5e to the 7 plus 40 equals plus c, so it's got to be equal to 40. So my particular solution of this differential equation is y is equal to 5e to the x plus 40. That's what my c is. That's what my constant is. And that's my particular solution. Now, last but not least, they wanted to know what is f of 0. So y is equal to 5e to the 0 power plus, plus 40. Anything to the 0 power is equal to 1, so 5 plus 40 is 45. And my answer is 45, isn't it? Using the particular solution. So let's look at actual AP exam questions because, like I said, they come up almost every single year. So we're going to take a look at what it looks like to find a particular solution. Usually that's letter C on this. Usually they have you try to sketch the slope field, and then they want to find a particular solution. And they gave us a condition, they gave us f of 1 is equal to 0. So what do we have to do first is we have to get our separation of variables. So we have y minus 2 to the negative 2 power, because we're dividing by the y minus 2 squared, dy, is equal to 1/3 x dx. I separated my variables there. Okay, I got my y's on one side, I got my x's on the other. Now it's primed and ready to integrate, isn't it? So what's the integral of y minus 2 to the negative 2 power? Well, we're going to use the reverse power rule. We're going to get y minus 2 to negative 1 and negative. Okay, we're dividing by negative 1. We're dividing by this power that I have right there. And I have 1/6 x squared plus c. Think of the reverse power rule. That 1 goes up to a 2, then we divide by 2, which gives us 1/6 there. Now that is, right here, is my general solution. That's my general solution. That's not my particular solution because I haven't plugged in anything yet. That's just my general solution. Now I'm going to plug in what I know. I know y is equal to 0, isn't it? 0 minus 2 to the negative 1 power is equal to 1/6 when x is equal to 1 squared plus c. So what do I have here? I have a negative 2 to the negative 1 power. That's 1 over negative 2. That negative cancels out. So we have 1/2 is equal to 1/6 plus c, which means I got to get some common denominators, don't I? I'm going to get 3/6 equals 1/6 plus c, which means I need c is equal to 2/6 or 1/3. So now I know what c is. Now I have to finish this out and find my particular solution. So I go back to my general solution. I know this is negative 1 over y minus 2, because that's y minus 2 to the negative 1 power, equals 1/6 x squared plus 1/3. Okay, so I got to clean this up a little bit. We're not done yet. We got to clean this up and solve for y. We got to get everything over the other side to solve for y. So I'm going to get common denominators over here. Okay, so I have x squared. I make this in the 2/6 plus 2 over 6. That's my common denominator 6. Okay, 1 over y minus 2. Negative 1 over y minus 2. I'm going to move my negative over. Okay, which means this guy is gone. I'm going to do the reciprocal of everything to get the y minus 2 on the numerator. So y minus 2 equals negative 6 over x squared plus 2. I just flipped everything. Now I'm going to add 2 at the end of the day. So y is equal to 2 minus 6 over x squared plus 2. And that is my particular solution. That is my answer, my particular solution of this differential equation. You can see the easiest thing to do right off the bat is separate your variables, you integrate, you solve for your c. Then you plug your c back in and you solve for your y. You can see this is going to be worth a lot of points, okay? But there's a lot of points for the work. Oftentimes I tell my students, separate your variables, get your integration, find your c, go on to the rest of your exam and then come back and find your particular solution, because you can do it. It just is a little bit of work. That's it. Let's take a look at the 2016 exam. Again, find the particular solution. These show up, and they gave us an initial condition. These show up over and over and over again, almost on every single exam. So first we want to separate our variables. So we have 1 over y squared dy is equal to 1 over x minus 1 dx, which means I'm going to clean this up a little bit. Y to the negative 2 dy is equal to 1 over x minus 1 dx. And what do I have? I have my y on one side, my x on the other, which means I'm primed and ready to integrate, aren't I? What's the integral of y to the negative 2? Well, I'm going to use the reverse power rule, aren't I? And I get negative y to negative 1. And that equals, what's the integral of 1 over anything is natural log of x minus 1 plus c. Okay, so what do I actually have? I have negative 1 over y equals natural log of the absolute value of x minus 1 plus c. And now that's my general solution, isn't it? That's my general solution. And so now I'm going to plug in my particular conditions. Okay, when x is equal to 2, y is equal to 3. So negative 1/3 is equal to natural log of 2 minus 1 plus c. Natural log of 1 is equal to 0, which means c is equal to negative 1/3. So I know what c is right away. You can see I'm boxing the things that are very, very important as I go along, which means I know that negative 1 over y is equal to natural log of x minus 1, the absolute value, minus 1/3, isn't it? Now, what do I have to do? I have to try to get the y all by himself. So what do I have to do? I have to do the reciprocal, don't I? Okay, I have to do the reciprocal. So, and I have to move that negative over. Probably before I do the reciprocal, let's move the negative over. So I'm going to do it step by step for you guys. 1 over y equals, that 1/3 becomes positive, minus natural log of x minus 1. You can see how that negative moved over, made the 1/3 positive, made my natural log of x minus 1 negative. Now I'm going to do that reciprocal, move everything, just flip everything. So y is equal to 1 over 1/3 minus natural log of x minus 1. And you can see that right there is my particular solution of my differential equation. And that is how to solve and find particular solutions to DiffEQs. Takes a little bit of practice, but when you got it down, you got it down. See you guys. Bye.